Okay, question 3 is giving us a substance that the majority of us will not have come across before. So at first glance it does look like a complicated question, but actually it isn't. The first thing that you need to do is to look at the bonding. So it's asking us to predict the CSC bond angle in this substance. What I would do is start by visualising. This is my sulfur has 6 electrons. 2 of those electrons are involved in the covalent bonds to the carbons. So this cross here and this cross here are representative of that carbon-sulfur bond. Now, because sulfur has got 6 electrons, that means that I have got 4 electrons that are left that are unbonded, and therefore I have got 2 lone pairs of electrons. And you can see here that I've just indicated that on my sulfur. This is where I would always start with any question on bonding, or particularly on bond angles. Now, if we've got 4 bonding regions, which is made up of 2 bonds, and 2 lone pairs, there's a couple of ways that we can approach this question. So we could either use some knowledge, just standard knowledge that you've already learned. If I have got 2 bonding pairs and 2 unbonded pairs, then my bond angle is going to be 104.5. So that's something that you can just have as knowledge. Or you could have instead a slightly different bank of knowledge, which is that if I've got 4 bonding regions, my bond angle will be 109 degrees. Because I then have got some regions that are bonded and some regions that are non-bonded, for every lone pair of electrons that we have that is not bonded as opposed to bonded, what we see is that we have roughly a 2 degree decrease. So because we've got 4 bonding regions, but 2 of those bonding regions are in the form of lone pairs, we have 109 degrees and we take off 2 degrees per lone pair to give us 105. So the answer to this question will be accepted anywhere between 104 and 105. The information that you require to get the full 3 marks: first of all, we've got 2 bonded pairs, we have 2 lone pairs, and then you need to stipulate that lone pairs repel more than bonded pairs. So that's what we were talking about when we were saying the 4 bonding regions, but we have that minus 2 degrees for every lone pair. So this is to do with your valence shell electron pair repulsion theory. The next question is asking us for 2 things. It's asking us why it's got a low boiling point, and then also why it's insoluble in water. The answer to all questions on boiling points is always the same. If anything from GCSE, anything that has a low boiling point has so because it has weak intermolecular forces of attraction that require a small amount of heat energy to overcome or to be broken. So that is what you need to include for anything on low boiling point. 2 points. One is to do with the intermolecular forces, and one is to do with the amount of energy that is required to overcome these forces. And the opposite would obviously be true if it was a high boiling point. The next thing is to do with solubility. So do remember that there is a connective in the question, and therefore 2 points you need to make. Solubility, it doesn't form hydrogen bonds. And the reason it doesn't form hydrogen bonds, despite the fact it's got hydrogen, is that it doesn't have that oxygen or that nitrogen present. So yes, it's got lone pairs, but no, it will not form hydrogen bonds. And because it doesn't form hydrogen bonds, it is not soluble when we try to dissolve it in water.